Hello and welcome. This video is a step-by-step instructional guide to the third exercise in RTsim.Career called Heat Exchanger. Let's get started. Let's click on the training mode and choose Normal Startup of the Heat Exchanger. At the beginning, I want to remind you that heat exchanger is a device that cools a gaseous product to the required temperature, causing condensation to occur. Its operation is based on heat transfer between two media through the walls of tubes. Why heat exchanger is needed? Heat exchangers are used to cool products so that they do not vaporize inside pipelines. After distillation, fractions must be cooled rapidly, otherwise light hydrocarbons would simply evaporate and be lost. Dear friends, you may ask me, why is this important? And I will give you some statistics. Up to 40% of refinery energy consumption is associated with heating and cooling processes. Without heat exchangers, fuel consumption would increase dramatically. Safety is also critical. If products are not properly cooled, pressure may rise, leading to emergency situations. Improper heat exchange results in losses of light fractions or deterioration of fuel quality. Let's speak about design of the heat exchanger. Heat exchanger condensers can be of various types, with shell and tube units being the most common. A shell and tube heat exchanger is a horizontally oriented vessel. Stream number 1, assumed to be the cold stream, and it starts here, enters the shell, flows through it, and exits. It's heated by stream number 2, which enters the same vessel from here, but does not mix with stream number 1, as it flows through many thin tubes. As a result, the cold stream is heated and the hot stream is cooled. There are some processes that occur inside heat exchanger. There are condensation, cooling, and heating. Alright, dear friends, let's conduct the normal startup of our heat exchanger. Hope you remember that we need to click these two buttons for the begin. Start and Technological Flowsheet button. There is one very important feature for the beginning of this exercise. Please pay your close attention to it. When starting up any heat exchanger, we always initiate the process from the cold circuit. Why do you think we do it this way? Make your own hypothesis, pause the video, and then come back to us. So, the right answer is that this is done to avoid thermal deformation. Even though the temperature might not seem very high, if you start the heat exchanger from the hot side first, its tubes will warp and looks like spaghetti. That's why, remember, you always need to start any heat exchanger only from the cold circuit. And let's conduct the normal startup of it. Our first step is opening the manual valve Z number 16. Let's do it. Our next step is opening the regulating valve TIRC number 6. Let's go to the control. And let's open it, of course, smoothly, between 5 and 15%. Let's open the manual valve Z number 14. Is the third step. Our next step is opening the manual valves Z number 20 and Z number 11. They are here on the hot circuit. And now we need again return back to our TIRC number 6 and open it between 30 and 70%. But it's already opened. We open it to the 15%. Dear friends, it's not a problem. Click on the 15 and put here new number, for example, 30%. Then enable automatic mode to it. Click here at the man and enable automatic mode. And set the set point between 105 and 115 degrees Celsius. Let's go back to our workstation field. So you can see that our TIRC number 6 is falling because we set the set point 115 degrees Celsius. And when the device will go to this parameter, we can finish our exercise with a heat exchanger. Dear friends, some question for you. Could you tell me, please, where a heat exchanger is used in industry? Pause the video and make your own answers. So the right answer is heat exchangers are key equipment in refineries. As I already mentioned, they are providing up to 50% of overall process energy efficiency. Their correct selection and operation directly affect economic performance and operational safety. And, dear friends, that's all for today. We have successfully conducted our heat exchanger. You can see that temperature is close to the task. And now we can finish our exercise. Thank you very much for your time. I'll see you at the next session. Goodbye.